Hello, welcome everybody. It's my pleasure today to introduce our speaker for this month, Dr. Marjorie Chan. She is recently retired after a rewarding 42-year career as sedimentology faculty at the University of Utah. She has received recognition for her work, her Utah work in the past. She's a former recipient of the Lehigh Incy Award, as well as other teaching, research, service, and outreach awards from GSA, AAPG, and AGI. As chair of the U.S. National Committee for Geological Sciences, she actively helped lead initiatives in geoheritage and sampling ethics. And without further ado, I'll turn the time over to Dr. Marjorie Chan.
Thank you for having me today, and I'm really excited to share some things that are a little bit different than the typical geology research talks that I'm usually doing. But these are things that I think are really going to impact how things go forward in the future. And I think we're at a time when a lot of things are changing. And in particular, I think the landscape in the future for geology is going to be changing as well. And if we think about what are the things that might be changing in the future, well, number one, and especially with the U.S. National Committee for Geological Sciences, they've been concerned about how we connect with people around the world. And some of the things that help unify geologists and geoscientists are some of these ideas of, number one, geoheritage. This is about diverse landscapes that we ought to protect as scientists that understand the landscape. And secondly, ethics is really kind of a subset of geoheritage, and that we need to do a better job of making sure that people are following rules of ethics because it affects our own geoheritage. And then the third topic I want to talk about is technology, in particular, how things are changing and how important the fidelity of data are and the right kind of communication to get the kinds of products that we want that can move us forward in the future. So starting first with geoheritage. Geoheritage is one of the newest keywords that GSA has added to their list of keywords, like volcanology, sedimentology, etc., because they felt that this was a real important unifying concept. So geoheritage are areas of geologic features that have significant scientific, cultural, educational, or aesthetic value. And GSA has a position paper about this. And really, one of the things you might think about for geoheritage is it's a lot like geodiversity, the way biodiversity is for biology. Geodiversity is that way for our discipline. And geoheritage is trying to look at the whole picture of geodiversity over time and space and landscapes. So why are we interested in geoheritage? If you look here on the Venn diagram, you can see that geoheritage is meant to kind of intersect society and sustainability as well as science. So it's more than just what we do in our science, but it's how do we connect with society? And in particular, it's really important for us to have involvement of people that are in society, and so that they can see how these geoheritage sites are important to them. And some of the things that we need to focus on is respect for the rock archives. We have various areas that are the best or the pristine outcrops, and we really need to protect them because some of those might be important for future, science discoveries that haven't yet been revealed. And this whole idea of geoheritage is really an international movement that's been a part of UNESCO. And we used to be a part of that, and then because the US withdrew from UNESCO, we were not a part of that. And then we tried to get back into it, and then things changed again just last month. So right now we are not formally part of that UNESCO group, but geoheritage is still important in our future and something that we need to collaborate with. So geoheritage even has books and journals that are all about this topic, and that's something that's really grown over the last 2 decades. It's really about the diverse Earth systems and some of the change in interrelationships. And I think in the way that we want to involve society, it really means helping celebrate some of the geologic features. And it involves this global cooperation, which affects education, conservation, and tourism. And technology is also going to be an important part of this. If you look at some great examples of geoheritage, this is the area that's on the north coast of Spain where they have this spectacular flysch. These would be these repetitive sandstone beds that have climate cycles in them and are classic turbidites with numerous structures. And you can see how lovely the outcrops are along the coastline. And so what has happened in this community is that they really focus on everybody understanding what flysch is. You know, it's probably one of the few places you can go to where somebody at the grocery store might actually know what flysch is. And they made this Basque geopark, and they kind of celebrate people living on this area, you know, for centuries, and then just how important that landscape is to their heritage. In conjunction with this, they put together a volume, and that's this volume here that you can take a look at. This is the first 100 geoheritage sites, and this project was designed to really help people better understand geoheritage by having 100 sites every couple of years. So the first 100 came out, and Zumaya was in that one. You can see some of the examples of ripples and trace fossils. And I was there, and we were able to celebrate the opening of this first 100. This book is free online as a PDF, which is really great. And you could think of this as kind of like a bucket list of, if you thought, what are some of the most important 100 sites, you know, worldwide, this would be a good place to start, of places you might want to go to. And what's really nice is that they just do a 2-page summary of each site, and they just put what the most important highlights are, so you don't have to get drowned in all that extra stuff that you don't understand. You can just get the basics. And then the next project was the second 100 sites that just came out in August. And so I'll talk a little bit more about that second 100, and you can take a look at the books if you want later. So another thing might be geoheritage. What is another example of geoheritage besides that Zumaya Park I just showed you? Well, if you had an old limestone quarry in France, you know, what could you do with that? I'm hoping this will play. It says not programmable key not installed. What should I do?
Still going. There you go.
Oh, okay. So what they did is they took this old limestone quarry that has the nice white walls, and they turned it into a 3D multimedia show, which is a very immersive art environment. So by projecting on the walls the works of famous artists, they could actually utilize this geological heritage site and really make it relevant to people, and make it even a place that people would come back to because they rotate the art shows. And this is kind of really a spectacular example of utilizing an area in a very different way than you would think of doing it. But it's a way to integrate science and society as well as sustainability. Let's see. I don't know. Oh, I think I went forward one too many. Another example of mine is this salt mine in Romania, which I think is another example of a geoheritage site. This one, you know, you don't want to project things on the wall because the walls are so spectacular as they are, with all that, all those layers of deformed salt. But they do even, you know, have some of the history, like the mining equipment that was used there. So there's lots of ways to engage society through the geodiversity that's around us globally. Some of the things that we've done are to try to nominate sites. All of these sites that are in the book have to be nominated, and they're selected by a committee, and they go through a ranking system, and it's actually quite rigorous. So because of some of the issues that we've been having with the shrinking Great Salt Lake, I thought it was really important that the Great Salt Lake be recognized as one of these geosites. So this is in the second one that was just announced in August. And one of the things that I hope is that by having a international group say this site is important to us, maybe that is some ammunition that can be used to help save the Great Salt Lake. Another example that was proposed that is one that you're familiar with here in Utah is the Henry Mountains. And my colleague Marie Jackson proposed this one as the site where G.K. Gilbert defined the locality of Lacalis and came up with some of the ideas of mountain building. And sometimes we kind of don't even think about all the history that goes with some of these geologic sites that are key to our science and the building of our science. Another one that I proposed with one of my former students, Winston Seiler, is the wave at Coyote Buttes. And of course, you know, this is one of the most spectacular examples of colorful, wind sculpted Navajo sandstone that is in calendars and textbooks everywhere. And it's just so important that we recognize this because it takes a unique set of conditions to actually get this. So that's a little bit about geodiversity and the geoheritage sites. And so the second topic I wanted to talk about was the ethics of geologic sampling. And partly because this actually fits into the idea of geoheritage and trying to preserve some of the sites that are important to us. So on this ethics of geologic sampling, I'm going to talk a little bit about the background and then how we have different values in conflict, how we should actually promote ethics, and then kind of some of the recommendations that have come forward. And you can see in this example here from Scott Foss, who is a BLM officer, people are often doing things without permission on places they shouldn't. And, you know, on this particular site, it would have been very easy to just drill holes on the back side of the petroglyphs where there weren't any petroglyphs there, but unfortunately that wasn't done. So one of the things that's important when you talk about ethics is to really understand what is the current attitude that people have. I proposed that we should do a survey to actually see what people in our society actually think. So this was through the cooperation of all these geological societies that you see here. Although it was sent out to over probably 20,000 emails, we got about 800 responses back, and there were 46 questions. But still, even though it might be a small percentage, we did get some data that really kind of indicate what people think. And here's just an example on the left of Dinosaur Ridge. I think maybe some of you have probably been there and you've seen that grate that's up there in front of a volcanic ash that they don't want people sampling. And it's recessive enough as it is that I think they're afraid of losing it. So the background and context is that a lot of this was brought to the forefront in an article in the LA Times in July 2021. And very similar to the other picture I showed of the holes in the petroglyphs, one of the Caltech professors drilled these samples and left dozens of holes at another petroglyph site in Bishop, California. And so when this gets written up in the LA Times, it brings a lot of attention to our discipline. Like, what are those geologists doing? You know, why are they doing that on the petroglyph face? You know, who let them do that, etc. So this brought up a lot of controversy, and eventually Caltech was fined $25,000. And there was also another very similar case for UT Dallas, and they were also fined $25,000. So we don't want those kinds of things happening because it really makes us look bad. Here's an example on the Upheaval Dome Trail of Canyonlands. And right by the trail, you can see all these holes. And this really raises a question of what is the ethics of sampling and permits? I mean, a lot of times we get permits to sample, so we might have permission, but then the permitting officer doesn't know exactly where we're going to sample. And, you know, they're so overworked, there's no way that they can actually say, you can only drill right here, you know, because they don't know the scientific background of what you want to get, etc. But there's a lot of complex issues because there's cultural sensitivities, like should anybody even be allowed to core on a petroglyph site? You know, because that has meaning to ancient peoples as well as some of the generations today. And then, what's the relationship to this idea of geoheritage that I just talked about, and how is that affecting or degrading the outcrops? So a lot of this really leads to the values that are in conflict. So when we go out in the field, what are we thinking about? Did we get permits and permissions? And are we on sensitive lands? Is it indigenous lands? Or are they geoheritage sites? Is it public land? Is it private land? We have to consider all those things. And then we're often thinking about, why are we sampling? What's the impact going to be when we take a sample, and how long is it going to last? And what are we really going to do with that sample? A lot of times they're kind of vanity samples that we take and we just think, oh, that's so neat, and we're going to bring it home and stick it on our shelf. And we're the only ones that are going to see it. But really, will pictures suffice? And is it good enough to just take a picture instead? And so in particular, with some of these past examples that I showed and some of the ones I am going to show, continuing on in the talk, how does the sampling reflect on our discipline? And is it really necessary? And when does the sampling actually become geovandalism? Certainly if you're doing sampling without a permit and you deface rock outcrop, then it will be considered geovandalism. And so then the question is, after you've got the sample, and I'm guilty because I just retired and I had more rocks than I wanted to admit that I had, what happens to those samples? Because a lot of the universities don't want to keep archives anymore. And so what happens to those samples? And gosh, did I do a very good job of documenting them so that the UGS could use them in the future? I didn't do what I wish I had done. But we have to think about, what's the life of the sample? And COVID was a great example of some samples being reused when people couldn't really go out in the field. Some people were actually able to do projects on existing samples. So we want to assess the values, explore what kind of guidelines and aspirations we want for the future, and really think about how this should be integrated into our teaching and our research and our professional integrity. So you can see the geovandalism on this left side, where there's a track site that has 6 big dinosaur footprints, and somebody, drilled holes in them without a permit. And BLM was very unhappy about that. And who knows why they were doing that? Were they going to look at compaction under the footprint or something? We don't really know. Here's another example. It's not just in the US, but here's one in the Alps. And somebody was trying to get a hand sample here, but really way over sampled, took way more than they needed and left that scar. And this is actually a place that people go down and walk by the river. So I'm going to go through several cases, and many of them kind of relate to things that you might see here in Utah, where I think it's useful to think about, what are the values in conflict? Who's getting information from this? And what are they taking from people that, had nothing to do with that project? So this is the Moab Fault right by Moab, southeast Utah. And you can see the beautiful expression of the fault offset. And this is one area right in here where somebody drilled with a rock saw, presumably to look at deformation bands, which are really well exposed there, right close to the fault. And so that was done without a permit and was considered geovandalism. In another case here, we have these beautiful tufa towers that are from Lake Lahontan in Nevada. And you can see that some of the tufa towers actually toppled over. So somebody was trying to sample across those different layers. And then they also sampled here, or they tried to on the side, but it really kind of marred that beautiful patina that was on that particular tufa. Some other types of examples that you might see in the Book Cliffs. This was an area in Cretaceous Blackhawk Formation, and this was considered one of the very best places to see hummocky cross stratification. Okay, so that's this low angle stratification that's usually typical of shallow marine shore face types of deposits. And it was one of the few places where you could actually see the hummock, the antiformal hummock. And the oil companies would come there, and some group from the UK actually came in and they drilled all those big holes across it. Presumably, they wanted to know maybe how the permeability would change as you go across, or how the porosity changes with different lamina and laterally. But essentially, what that did is it ruined it for anybody else that came afterwards. Nobody else can take a picture of that hummocky cross stratification and have it look like it did before. And so a lot of people were very unhappy about that. Again, kind of done without permission, and really affecting a lot of people in the future that use that as a place to learn from. Here's another case from Miocene evaporites in southeast Spain. And this is an area where there's a riverbed that you walk along, and there are these spectacular walls of evaporite minerals. And the evaporite minerals are kind of this interlocking intergrowth, and it's very hard. So you think of evaporites as being soft, but this is a really hard outcrop. And it's actually a locality that many busloads of intro geology students go to, and they all have their shiny new rock hammers. And if you have that rock hammer in your hand, you kind of want to do something with it, and you want to hit something. So about half of the white marks that you can kind of see here are about at, kind of waist level where you would kind of hit. And you can see that about 50% of the marks are from students that have hit it on a field trip. And, there's lots of float around that you could hit instead of hitting it actually on the outcrop. Another example you might not really think that hard about is right in the Red Rock Conservation Area around Las Vegas, Nevada. And I was out with one of the interpreters, and we went to this area, and I said, "Why did people do that here?" And he says, "I have no idea." And he says, "But they're starting to do it in a lot of places." And so what people did was they just took gum and they stuck it on and made a peace symbol or whatever. And, you might think that's sort of cute, but if it's on the outcrop that you want to study, or the best example of something, you don't want gum covering it up. And more and more, I think people are doing things, and then it gets carried away. To me, this kind of reminds me of like the locks that people would put on bridges in Paris. They stick them on one bridge, and then pretty soon, that bridge is full of locks, and people start putting their locks on other bridges. And pretty soon, every bridge is loaded down with those locks. I think another example is graffiti. You can see that in this case, it's not necessarily geologists, but there's probably too many times when geologists have painted their spray painted their numbers for measuring a section on the outcrop. And again, what that means is that nobody can actually look at it without that mark there. And while you think nobody else cares, or nobody else is going to see it, you have no guarantee that that's the case. We can't really tell what's going to happen in the future. So overall, the survey findings indicated that most people try to minimize their impact, but might have oversampled on occasion. And I think that probably includes all of us. But about 74% of people that took the survey said they'd seen obvious sampling of previous geologists or geoscientists more than 4 times. So what that means is we're out there, and we are seeing a lot of examples that other people have been there because they've left some evidence that they've been there. So that's kind of disturbing. And then also, one of the questions we asked is, what's going to happen to your samples? And the 2 biggest answers, besides a designated archive, but if you put these 2 together, where I have the stars, most people either had no idea, or they thought the majority of them are going to go into the dumpster. And so again, that's kind of disturbing. We've collected the samples from all over the world, and maybe we did analysis on them, but maybe we didn't. And a lot of them are going to be thrown out, or they're not going to be of any use. So the community sense is that probably the fate of sample collections, and particularly legacy sample collections where faculty are retiring, is becoming more and more important. And while most people try to do the right thing and seek permissions, etc., a lot of us would have probably done it differently if we had to do it over again. Some of the things that were interesting is that people said the challenges of sampling are that oftentimes the rules are different depending on what kind of land you're on. So even on public lands, the rules for the U.S. Forest Service might be different than national park, that might be different than BLM, or et cetera. So there's a lot of inconsistencies in the rules. We probably ought to interact more with the stakeholders. And most people agreed that we should leave no trace. And that is very telling, because if most people have seen geologists at the outcrop more than 4 times, that's not leave no trace. So we need more aspirational statements to encourage awareness, and we probably need to be integrating more training into our programs. And it was interesting that about 63% said they never had any student training on sampling ethics. And mostly if they did have training, it was through personal mentors like their advisor or just their own personal investigation. And I thought it was interesting that some of the young people said that they learned more about being in the outdoors and how to conduct themselves through the outdoor rec industry than they learned from their own discipline in geology. So most people felt that we could use more training in academic programs, and 91% felt that there were cases for sensitive sites where there should be more review on the process of sampling and exactly where people are sampling. So in this case, I put, the sticker point, the great unconformity. And, if people were doing a lot of sampling there, it would really ruin that particular historic outcrop. So remediation is one possibility. And, I think that's a good idea. If you do have to sample, it's pretty easy to take some of the material and mix it in with a quickset cement and fill in the hole. Some people have said, well, if you let geologists do that, then the next geologist that comes around might actually drill in the same spot, and then they're going to have problems because their sample's going to have, concrete in it or something. And I said, well, look, if they're dumb enough to do that, they're dumb enough to get whatever they get. I'm not going to worry about that. So you might wonder, is it okay to bend the rules? Is it okay to, just briefly trespass or take a sample, lift a sample? And, what I would say is don't do it, because if you get caught, it really reflects badly on your employer. It reflects badly, as the Caltech case did, on our discipline. And there's often unexpected surprises. So those unexpected surprises could be Yosemite Sam there on the left that has guns. And even when I did some field work just 2 years ago down in Kanab, we had permission to be on the land. And the landowner actually was using a drone and filming us while we were doing the work that we told them we were going to do. So, I don't think you should be surprised that you might get caught on film if you're trespassing or doing something you're not supposed to do. So the other topic I wanted to talk about is promoting ethics. And a lot of journals are starting to think more about this. What should we do to make sure people that are publishing scientific work actually have done it in a responsible way? So the Geological Society of London has these rules that it must be collected in a responsible manner, and protected sites must provide evidence of permissions. So that's just part of the code for publishing. And SVP, because of the fossils, has mandatory standards as well as aspirational standards. But I think those are good ideas of things that we should try to incorporate more in the rest of our journals. So they say you have to have all the necessary permits and permissions, follow all the rules and regulations, have the highest standards of interpersonal conduct, and act as ambassadors for our profession. And then they have these other aspirational standards. And probably aspirational standards are better if people will pay attention to them than mandatory ones, because mandatory ones are difficult to enforce. When people were asked what kind of advice would be helpful for you, some people said provide more information, repositories and flowcharts, like have checkoff lists of how to go about sampling. And when somebody's actually doing a research project, do you actually have a step-by-step thing of what you're going to do, or how many samples you're going to take, or are you just kind of get out there and however the mood strikes you, you take 20 samples or whatever it is. Maybe we ought to be thinking more about what we're doing and getting guidance from people that have done that before, especially in some areas where it might be sensitive or sometimes when it's in different countries. We also got a lot of response about archiving. People think that archiving is really important and that some things should go in a database with the right kind of metadata to show where it came from so that people could actually physically possibly exchange samples. Maybe if you wanted a sample from, a sicker point, somebody might have already taken one and you could use that, or you could use the powdered samples or whatever it was separates that they might have. So eventually we need more long-term data standards about the provenance and all the physical specimens, even if they aren't all in one place, like a USGS sample repository. If we know where they are and we can access them, we could say, okay, there's, these number of samples that some are here, some are in Germany, some are over here, but at least we know what there is and we can investigate further. So I want to kind of bring the idea of ethics and geoheritage to a case that I thought was very interesting. I think most of you know that I've spent over 20 years thinking about concretions and these cemented mineral masses that are sometimes called Moki marbles on the Colorado Plateau. Some of the best examples are in Grand Staircase, Escalante, shown here. And so I call this the case of the missing marbles. We were looking at these and thinking about them, and then BLM came to us and they said, there have been some crimes committed, and this happened in 2012 and 2015. So they were investigating the theft, transport, and sale of Moki marbles from federal property. On the left, you can see the examples of the before pictures that we had from some of our studies. And on the right, you can see some of the after pictures. They're not exactly the same perspective, but they're pretty close. And so you can see that a lot of the concretions had weathered out of the outcrop, and they were these beautiful lags that are on this nice flat surface. And then here, somebody came in with a backhoe, drove the truck up there, and then used a backhoe to kind of scoop up a lot of these marbles into piles and then to take them. So BLM needed proof that the marbles were from Grand Staircase. So you can see the picture before on the left, and most of these are like golf ball sizes. And then you can see the picture here on the right where all this area has been disturbed and they were scooped up. So I thought the before and after pictures were kind of sobering, especially when you saw how things were distributed on the left and then all these remainder piles that they left on the right. So when we were taken to the BLM warehouse, they sought my advice on what to do and how to figure out whether these were the actual marbles that were stolen from that area. So in 2012, they confiscated 64.5 buckets from a garage in St. George. And then in 2015, they confiscated another 39 buckets. So these are those 5-gallon Home Depot orange buckets. And we counted, and there are about 390 marbles in each of those buckets. We didn't count every bucket. We just took a representative bucket to count. So that comes out to over 42,000 marbles, literally tens of thousands of those marbles that were taken off of federal land. And what was interesting in this case, we could actually tell what the value was because these are sold on eBay or by rock shops. So we could say, okay, we have 42,000 marbles and the average price of these marble is $12 or whatever it was. And so then BLM could prosecute because there was an actual value that had been assigned to those. And so they said that actually it was one of their most successful cases because there was a value that could be assigned to the damaged property. So just so you can see what kinds of evidence we used to say that these were actually the ones from Grand Staircase. We use the size, where we have this unusual golf ball size. We use the geometry and the shape, which is these nearly perfect spheres, to some of the ones that are stretched out like a flying saucer. There were very distinctive ridges along some of them that actually follow the Aeolian lamina. And a lot of the outer surfaces had certain textures of being very smooth, almost like a rock varnish to some being like an avocado skin on the upper right. And then in the internal structure, they were typically rinds. So you can see one that we had from a previous sample and then one from BLM. And so we had that evidence, and the mineralogy was also distinctive in that it was primarily goodite, FeOOH. So in the end, all of this took about 5 years, 2 years of an investigation and 3 years of litigation. And finally, they had felony charges against 4 individuals, and all of them pleaded guilty. They all got supervised release, and most of them got a fine. But the one that got the biggest fine of $10,000 was the one that was a rock and gem dealer. Even so, $10,000 isn't that much considering what they took. The problem was what to do with the marbles afterwards. So again, BLM asked my advice, and so there were so many of them. I said, because they were weathered out like this, and most geologists want to look at things that are in situ, probably putting them back where they came from wouldn't be such a bad thing. So some of them were returned to the setting, although I'm not sure that they had a sign like I suggested that they do. Some of them went to visitor centers and museums. Some of them were actually distributed even by the UGS here to K-12 teachers. The main thing was that however they were used, because they were recovered property from BLM, they could not go in anybody's personal collection. So you couldn't own it. And then some went into a public display, which I show here, I think. We took some of the marbles and we set them in a kind of a sculptural display where we used a backdrop of the golden stone that's from the Chinle Formation. The reason why we didn't put it in Navajo sandstone is that the Navajo is just, even though that's where that originally came from, it's just too soft, and it would just kind of, over the years, be a pile of sand if we left it. So I thought this was kind of an interesting story on how we can get involved and actually use our science for an idea, for a project that relates to ethics as well as geoheritage. So in the final analysis, to recap the ethics, we wrote an article that summarized the survey results, and we came up with this kind of checklist of things that people could think about when they go out in the field. And the bottom line is that ethics should be a discussion topic and a part of a training. So I'm glad that you're letting me talk about it today, because I think we kind of have a lot of it in the background of our mind, but we don't really bring it to the forefront and talk about it. And that we should be sharing information widely using digital technology, and we should build on our current and future efforts for societies. So possibly some of the societies could be the hub for knowing where samples are, and they could manage and maintain a database, letting scientists log in their data, maybe eventually with all these international geologic numbers that are assigned to samples, kind of like a barcode type of thing, so that all samples are uniformly cataloged. And then eventually we need to consider what the repositories are. And unfortunately, some of the repositories are getting fewer and fewer. Okay, so the last topic I wanted to talk about, and I'll only do this briefly, is technology, because technology is really changing a lot of the directions of where we're going. Open data sharing has become more and more important. And I know I was talking about this 20 years ago, but open data sharing can really add to new discoveries and visualization, and really help us meet the challenge of bigger problems that are important to our society. I think everybody is probably using this. How many people are using this app, Rocked? Only about half. Well, I think more of you, everybody should be using it if you like to know what the geology is around you. And this is a free app, and it is developed by Shannon Peters at the University of Wisconsin. And you can actually use the GPS on your phone or wherever you are, as long as you have cell service. And then it'll tell you what the stratigraphy is of where you are, and it'll give you a geologic map that you can zoom in and zoom out. And then you just tap on the color of on the geologic map, and it tells you a description of the unit. just like if you had a geologic map. And so it really is handy. And even people that are not in our science are using it. And I think this is actually making our science more accessible to other people. Eventually, maybe all geoscience data should be on a Google Earth type platform, some kind of a GIS platform. And they've already done this for, NASA has done this for some of the planets. So it's kind of easy to do it because there's not as much data for the other planets as there is for Earth. But they have Mars Trek and other planet bodies. And then eventually, more of this we hope will apply to our situation here on Earth. And the USGS is getting involved, and they've proposed having a project on the geoheritage sites of the nation. And so they want to develop an inventory and have it keyed into kind of a GIS framework so that it'll raise awareness and make some of the mapping topics more accessible and relevant to the public. So these are some of the things that are probably going to be happening in the future. So I think the bottom line is that our landscape is changing pretty dramatically and pretty quickly. And some of the things that we really need to consider are geoheritage and geodiversity, kind of assess what our values are, and really try to build community and visibility around the important landscapes and geosites. So a lot of times this means sharing our story, also often going beyond our comfort zone of just doing our science with our heads down. But it's really the broader impacts of what we're doing and making it relevant to the rest of society. I think a second thing is that the sampling ethics is really relevant to geoheritage. It's also relevant to our profession and who we are and what we want to continue to do, and making sure that we have good sample repositories and access through digital apps is also very important. And so finally, the technology is going to be really key to leveraging a lot of the data management, more data than we've ever had to deal with before, but it really will help us make new discoveries and provide new ways to engage students as well as society. So I'll just leave you with this last slide about, I'm hoping that today's topic maybe caused you to rethink a little bit. Maybe on the left, what we used to do is go out, take a sample, and maybe kind of like a trophy head, hang it on our wall or put it on our shelf. But maybe it's better to leave no trace, take only pictures, leave only footprints, etc. Leave no trace. And then also think about, if we have rocks, the secret to contentment is knowing which rocks in life to let go of, what to hold, and which to let go. And I think as some of us retire, we're realizing we have to let go of a lot more rocks than we thought. So that's all I have to share. Thank you for listening.